Okay, good afternoon. Thank you very much for the introduction, and first of all, thank you very much for inviting me to this important meeting. Thank you, Aida. So, as you can see on the title, Yellowway 1, developing new disease-resistant banana hybrids. So I'm going to tell you a little bit about the process and also about the background of this initiative. So first of all, what is Yellowway? I think it's good to make that clear from the start. So Yellowway is a joint venture between Chiquita, Keygene, and Musaradix. Most of you will know Chiquita. Keygene probably is not so much known, but Keygene is a company in the Netherlands owned by 4 major breeding companies that jointly invested in a company to develop technologies to accelerate breeding. So they develop, for instance, markers for resistance or technologies to very quickly identify the sequencing of genomes. So to really generate know-how to accelerate the breeding program. And Musaradix is a startup that I co-founded with a colleague of mine. So these are the 3 shareholders in Yellowway.
Estoy cosechando casi toda la plantilla que no me imaginaba que iba a cosechar toda la plantilla.
So what's the purpose then of Yellowway?
Era una prueba.
So our philosophy is that we have to diversify the banana crop. So all of us know that, I think it's on the next slide, yes, all of us know that only about 15% or so of the global production is being exported, 85% is domestic markets. Cavendish represents more than 50% of the global production. From the agronomic perspective, that's a risky business. And we all know that Cavendish is very susceptible to black Sigatoka. So the number of cycles to control the disease is only increasing, super susceptible to tropical race 4, so it's time for a change. And the change should not come by only one variety. Said, okay, let's improve Cavendish 2.0, genetic modification, resistant to TR4, bingo, that's already been done, and we're also involved in that research. But our philosophy is that sustainability comes from diversity. So not only one replacement of Cavendish, but you open a breeding pipeline that's continuously developing new varieties. So that's the principle of how we want to and how we see the global future banana market. So Fusarium wilt, as you can see in this slide, severe chlorosis caused by the occluding vessels of the xylem vessels of the banana stem. So that causes wilting. Meanwhile, there's massive spore production also in the soil. Eventually, the plant dies. And Ecuador is in a difficult position, right? Because tropical race 4 is in Colombia and also in Peru. And I show you a couple of examples.
Con los productos del grupo grande hemos bajado en una área el 100% que fue, no puedo decir que fue un poquito aquí, fue un poquito acá, no, es todo, el 100% lo perdí. Los resultados hablan solitos. Vamos la segunda, porque aquí también el grupo grande, pucha, vamos para la segunda.
Just to refresh our memory, Fusarium wilt is not new to the continent. Previous century, around the time that I was born, in the 50s, there was this shift to Cavendish because eventually the banana production could not sustain like Gert Kema. So there was collapsing to Fusarium strains that we collectively call race 1. And one of the ways to deal with the disease was inundation, as you can see here. And inundation is still very effective. But in those days it didn't work because there was no tissue, right? So all banana plants multiplied by suckers. Many of these suckers were already infected. You couldn't see it, and that just boomed the epidemic. Up to a level that it was impossible to grow bananas in many regions here in Central America. So replanting, as I said, was just done by suckers. And of course, after the inundation, you just do not only kill Fusarium, but all the beneficial organisms in the soil, including nematodes. So that eventually didn't work. And that's why the details are not important in this slide, but it's just an historical overview of the introduction of race 1 strains, the collapse of Gros Michel, and then also the dissemination of race 1 through the ages. So what you see here in the 50s, Gros Michel was replaced by Cavendish. And the very reason was that Cavendish is very resistant to the strains that caused that previous Fusarium wilt epidemic. And the curious thing is that Cavendish is still super resistant to those strains. Right? So Cavendish is very susceptible to the tropical race 4, but highly resistant to all the race 1 strains. And that's already ongoing for more than 70 years, which is absolutely a unique example in the history of agriculture. A single variety with such a durable resistance. But what you also see in this slide is that despite growing Cavendish, race 1 simply continued to spread. So it did not stop the spread of the disease. Why not? Because all the soil is contaminated. But if you have a resistant variety, you can just give up by security, right? But by traveling, driving tractors, walking, you just continuously spread the disease. This is Cavendish, monoculture, Urbaeus, here the example. And as I just said in the start, more than 50% of global production, one single variety. Well, as I already said, right, from the agronomical perspective, that is very, very risky. And I have to say, you barely see this in any other crop. Maybe in forests, but that's about it. And this is then the summary of the dissemination of tropical race 4 around the world. So what you see here in this slide is that in the 60s, Cavendish was already affected again by Fusarium wilt, but that was in Taiwan. In retrospect, we identify, hey, that was caused by the strain that we now call tropical race 4. Since 2013, when we identified it for the first time outside Southeast Asia, up till now, 10 years later, it was introduced in 17 new countries. So this should not make us very optimistic on biosecurity, right? Because despite all the measures that were taken, the disease simply spreads. If you look into the spread of Colombia and Peru, for instance, all the data indicate these were independent introductions. So the strain in Peru is dissimilar from the strain in Colombia. You cannot accuse Colombia for the introduction in Peru. It's just a different strain, right? So this is a scary story. Eventually, TR4 will spread further across Latin America. There's no question. The question is simply when. So, over the years, we have really invested a lot of time in describing the diversity of these Fusarium fungi that cause Fusarium wilt. The details of this slide are not important, but what is important to remember is that race 1 is a complex of genetic lineages that are dissimilar. So it's not just one single genotype. Whereas what you see in the blinking mark, that is tropical race 4. And what we have shown is that all the strains of tropical race 4, irrespective from which country, that's truly a clone. So whether you take a strain of tropical race 4 from China or from Peru, they are 99% similar. And what is also very important to remember that tropical race 4 is not a mutant from race 1. It's really a new lineage that originates from Southeast Asia and has spread around the world, as I showed in the previous slide. Until 2013, just in Southeast Asia, since 2013, around the globe. So I want to go with you to a case study, and this is Peru. So the introduction in Piura. What we decided to do with the Dutch company and the various partners in Peru is to map the banana region by an aeroplane. So we can use satellite images, we can use drone images, but the disadvantage of a satellite is that you have clouds. A drone is very difficult to map out 20,000 hectares. With a plane, that's rather easy, as you can see here. So we mapped more than 70,000 hectares in 12 flights, 2,000 feet altitude, more than 130,000 photographs packed into a map of the banana region in Piura. So this is the map. You see the Poechos reservoir, and then the first introduction of tropical race 4 is indicated on the map, first case, and then we found it later on in those other areas with indicated by the arrow. Sequence all those isolates if you compare all those data, since there were rumors that it was not truly tropical race 4, well, to make a long story short, if you accumulate all the data, you take the first incursion strain, all the other strains that we have isolated there, sequence them, one and the same thing, tropical race 4, no question about this, right? So, all the stories that this is probably not tropical race 4, just put them in the waste bin, nonsense. It's TR4 and it's different from the TR4 in Colombia. So that's already a warning sign, right? So despite biosecurity, we have an additional new strain arriving in Peru. This is just a map of the irrigation channels, and those irrigation channels all are sitting on the Boetius Reservoir. Now, Fusarium wilt can spread easily by water. And so having a production area of the Boetius Reservoir, of the pure area is about 70,000 hectares, 10,000 hectares is banana, 8,000 growers, so far majority smallholders. They all sit eventually on one and the same irrigation channel. And if you map through time, you see that the fungus is jumping from channel to channel. And at this stage, I believe that more than 30% of the area is already affected by TR4. So April 2021 was the first incursion. In June 2023, that was about 200 cases. Then you see here June this year, 440 cases, and September this year, 535 cases. More than 30% of the area affected, and this area exports about 25% of the global organic banana market. If you ask me very frankly, for many of these growers, eventually game over. The whole area will be contaminated with TR4. Don't think you can control this with trichoderma or whatever. Forget it. It's not going to work. Cavendish is super susceptible. What you need here eventually is new varieties, resistant varieties. And Cavendish is the perfect example. It's in front of our nose already for decades. You can plant it on the most infested soils, no problem. It's resistant to race 1, right? And that resistance is available in wild germplasm. So that's why we kicked off the Yellow Way initiative and said, we have to breed new varieties. We have to deploy all that rich diversity in wild banana accessions that is just not being tapped. There are only a few breeding programs around the world for banana, despite the importance of the crop. So it's time for a new program. So Africa, just a quick update. TR4 was introduced in 2013 in Mozambique, and then here you see in 2021 in Mayotte, in 2023 in the Comoros. Again, a sign that it's very, very difficult to contain the disease, right? Mayotte and the Comoros are islands off the coast of Mozambique. Fusarium cannot travel naturally through the Indian Ocean. So humans are the vectors. We transfer the disease by being in an infested area and travel ignorance and drag the disease along to new areas. And that has been shown over and over again. So water, yes, disseminates this very efficiently, but we are responsible for the international and intercontinental jumps. I already mentioned Southeast Asia, right? So since the 60s it has been spreading across Southeast Asia, and then in 2013 it moved to Jordan, and from there to the other countries. So I'm sorry to say, but we definitely should not be optimistic about containing tropical race 4. All the data show that it's extremely difficult. And that's true for any soil-borne disease. Talking about ignorance, this is a photograph of the Dominican Republic. An entrepreneurial grower started a 9,000 hectare plantation. I met him a few years ago. He had never heard of Fusarium wilt, let alone tropical race 4. And these are people that can travel around the world, right? So there's still a lot to do in training and prevention measures. What you see in the inset there, that is this map.
Ecuador tiene más de 1,000 empresas certificadas.
This is a test of all the banana varieties that are currently produced in Cuba, just as an example. And we tested all that material with TR4 and with race 1 strains. This is the TR4 map. So if TR4 would ever arrive in Cuba, of course it will not wipe out banana production in Cuba like this. That's going to take time. But look at the Philippines. It's now for about, I believe, 15 years in the Philippines. The export volume of the Philippines has dropped down by 40%. Is this only TR4? Likely not. But it's a very significant share, right? So it's going to take time. Fortunately, Fusarium wilt is slow, but it's devastating. If it would ever arrive in Cuba, 70% of the germplasm that's being grown in Cuba is highly susceptible to TR4. So what you see on the right side of that panel, those are plantain varieties. So plantain is doing pretty well. Don't be mistaken, I'm not saying plantain is resistant, please. Don't copy me and plantain is resistant, that's not the case. It's way less susceptible. That's what you see here. In Ecuador you have a very significant area of plantain. If you ask me frankly, catalog that germplasm and screen it as quickly as you can to TR4. You just need to know whether the material is susceptible, yes or no. Right, so we need really activities. Okay, let's move to black Sigatoka. We know the disease. This is an entirely different fungus, airborne, and this disease is genetically extremely diverse. Each and every isolate that you take from the field is a unique genotype, like all of us here in the room. If you would take a DNA prep from us, you will see there is as many genotypes as many people we have here. The same is true for black Sigatoka. So what we did is we developed for Fusarium, but also for the fungus that is causing black Sigatoka, which is called Pseudospora fijiensis. We developed what we call a pan-genome, which essentially means you take about 100 isolates, you sequence all those isolates, and put all those sequences on top of each other. And this gives you kind of an impression what is now the genome diversity of that fungus. So to make a long story short, you see the green balls and the gray balls. The gray balls that you see here, and each vertical line is an isolate. Okay?
Elige Conecta Air.
Donde volar es un placer.
So we sequenced about 100 isolates, as you can see here. The gray balls represent chromosomes that are always present. The green balls are chromosomes that can now and then be missed, as you can see, because you see holes in that table. And that's very characteristic for this type of fungi. So they have a pretty large chromosome set, let's say 20, but they can easily miss chromosomes, still survive, still have sexual reproduction. That's not hampering them at all. But it shows you already how diverse and dynamic these fungi are. So why do you have to increase your fungicide application all the time? Because you put selection pressure on the population, the fungus has sexual reproduction, so you select for strains that are more and more resistant. That's why you have to spray more and more. So eventually there is an end point, right? In Costa Rica they already spray 70 times. Fortunately not the case in Ecuador. But that's another reason why you need new varieties. And of course, tropical race 4 is threatening. It's an absolute threat to banana cultivation. But black Sigatoka is a day-to-day concern, right? So from many points of view, Sigatoka is way more important. As long as TR4 is not in the country, of course, invest in biosecurity, prevention, training, that's all clear, but it's not affecting a grower. Whereas Sigatoka is everywhere. So this is just a detail to show that we have also developed the genetic technologies to really understand these fungi. And for instance, why do we do all this sequencing? We want to identify which genes are now responsible in that fungus to kill banana, to make a long story short. Well, one of the ways to do that is you have candidate genes because you have all those genome sequences and then you knock out genes. You just stop them. And that's what we do here. So we use CRISPR for it. That's a very precise genetic modification tool. And what you see here in this, in the right panel you see Petri dishes, and the black one, that is the wild type. So if you grow Pseudospora fijiensis on an agar plate, it's turning black because it's producing melanin. So if you knock out that gene, the fungus turns out to be albino. That's all the orange discs that you see. So it's not producing melanin anymore. So what you can see is that is in the table on the left-hand side, PKS 10/1. So there you see the efficiency of that technique, right? So 95% efficiency of knocking out a gene. That means that almost every mutant you pick is a knockout, right? So these are tools that are essential to understand the lifestyle of the fungus. Now, this gene is interesting, but of course, as I said, we are interested in the genes that are really responsible in killing bananas. And since that population is continuously adapting to new fungicide applications, then you see this picture emerging. So what you see in the bars, for instance, for Costa Rica and the Philippines, you see that the bars are more and more to the right-hand side. They turn red, and that means those strains or those populations become increasingly insensitive to fungicides. And in this case, these are DMI fungicides, so the azoles, right? So you have to increase your frequency of application to keep black Sigatoka under control. So as I already said, our philosophy in Yellow Way is that we have to diversify the banana crop. Go to any other crop, particularly to the annual crops. I mean, cacao, of course, coffee. There is some diversity, but in perennial crops it's more difficult. But go to any other crops, we have plenty of varieties. Now, that is our vision for banana production in the future. That each of you are growing banana, you can pick your own choice. Which banana do you like? Is it the taste, is it the productivity, etc. So you can do that by breeding. And what we do in Yellow Way is classical breeding, but using the latest genetic tools to accelerate breeding.
Con un control en el laboratorio y ver cómo vamos bajando la población de
control diseases. Fusarium important, but also for black Sigatoka. You know, we eventually arrive at a way more sustainable banana production. Now, what we do in Yellow Way is knowledge-based breeding. So,
con los productos del grupo grande hemos bajado en una área el 100% no puedo decir que fue un poquito aquí, fue un poquito acá, no, es todo el 100% lo perdí. Los resultados hablan solitos. Vamos la segunda, porque aquí también
banana originates from Southeast Asia, there's plenty of diversity. You can just cross those accessions and you have, like in any other cross, you have a population, a segregating offspring that is in the seeds. Right? So if you cross diploid seeded bananas, you get segregating populations. And in those segregating populations, what breeders do is to select the best plants out of those populations. That's the job of a breeder. So we took a collection of wild germplasm, sequenced all those accessions until we had a pan-genome of banana. So we know exactly the organization of the banana genome. As I said, we did the same for Fusarium and the same for Pseudomonas parvigensis. So packing all that knowledge together, we can direct a breeding program towards resistance.
Y estamos haciendo justamente cada actividad.
This is an example where the details are not important, but here you can see the differences of, for instance, a wild banana accession compared to the model diploid AA banana type, which is called Banano. So that has been sequenced, and you see in that KG2 the difference is 2 translocations. And that means one part of the chromosome is transferred to another part. And that is affecting, for instance, fertility. And so you can also predict whether your crosses will be successful, yes or no. But in addition to that, we have done really a substantial effort in phenotyping. And what I mean is scoring for disease resistance. And since we work in the Netherlands, we don't have any risk because we don't grow bananas, so we can use multiple strains of Figensis, the same for Fusarium, and screen all that material for resistance to these diseases. So we have cataloged the resistance, here you see an example, in all that wild germplasm for resistance to Fusarium wilt as well as to black Sigatoka. And then based on that information, we have made the crosses. And in the process, we can not only predict, but also show whether offspring is resistant, for instance, in this case, to tropical race 4. Because since we have the sequences, we have and we have the phenotypes, we have identified the places on the chromosomes of those accessions that is responsible for resistance to, for instance, in this case, tropical race 4. So you have those markers, right? So if you make a cross, you can select in your offspring those individuals that carry those markers. The individuals that don't carry the markers, you just throw them away. They are useless. They will not be resistant. And so this is really accelerating the entire program. So eventually you actually can compare it to what I show here as a Lego example. We have also sequenced Cavendish, so we know the exact genome sequence of Cavendish, so you know how Cavendish is structured. Right? So you can choose your parents in such a way that your offspring is getting pretty close to Cavendish. And we all know that Cavendish is well received in the market. So what we do is essentially replace a few blocks in that construction of Cavendish that are responsible for resistance to tropical race 4 or black Sigatoka. And so we are not producing a new Cavendish. We are producing new varieties, but we can direct the program that the results will be close to Cavendish varieties. And therewith you secure, for instance, productivity or transportability, which is also very important. But I hope I have shown you that you generate diversity by starting breeding. So the curiosity of our program is that, yes, we breed bananas in the Netherlands, not in the tropics, and we make all our crosses in a greenhouse. And in over 95% of the cases, those bananas flower in the greenhouse, and we have plenty of seeds, and we cross year-round. Right? So we don't have to go to a specific geographical spot in Uganda where this accession will flower and then we can make the cross. No, we continuously cross and also back cross. Right? And this all takes place in a greenhouse. And there's not a huge greenhouse, it's smaller than this room. So what we developed so far is what you see in this slide. So we have a greenhouse where we make all our crosses. We have a deep knowledge on disease resistance in all the accessions. We have genome sequences of all those accessions as well as from the fungal pathogens we focus on. We have a cell and a tissue culture lab. We have a mutagenesis program, and we are running field trials in the Philippines and in Indonesia. And the timelines is what you see here. So I already said, right, we start with diploid wild material. So we develop the perfect parents. Then we make from those diploids, we make tetraploids and cross them back to a diploid, which results then in triploid seedless varieties. We made our first cross in 2018. The program really kicked off in 2020. In this year we had our first TR4 resistant triploid. Is this right away a cultivar? Of course not. But it shows you how quickly it can go. So in 4 years a triploid is resistant to tropical race 4. Believe me, that's unique. Right? But breeding is a number game, it's statistics. So you need lots of progeny, test that under field conditions, pre-select for the markers that I just explained, and the rest of the material, bring it to the field, and that's where you do the selection. And that's done. The first triploids that we generated are called Yellowway 1. We are now in 2024. The prediction is that in 2028 the first varieties will be ready. So this is what I already said, right? We grow it in the greenhouse, the results are there, and we field trial them in the Philippines for tropical race 4, for black Sigatoka, and on the same in Indonesia. And those locations are important because, for instance, for black Sigatoka, there's tremendous diversity also in that area. And for Fusarium, of course, we have infested tropical race 4 farms that we can use for screening, in addition to the field. So is Yellowway now only breeding for Chiquita? That's also something that I hear frequently. No. Yellowway is a joint venture. 70% is owned by Chiquita, but Yellowway is a breeding company. So we can sell and license out varieties to anybody who's interested. We collaborate with IATA breeding program in East Africa for food security, cooking bananas. You know, we can mutually benefit from those programs. The tools that we develop can be used to develop other varieties that are very important for domestic markets. So it's not just about export. Export is very important. Yes, we want to have replacements for Cavendish, and more than one. But in addition to that, we're also developing other varieties, for instance, for niche markets. But the varieties we develop, they are for sale. So this is the timeline already mentioned. So we expect to have the first commercial varieties available in 2028. Just to finish off, I'd like to draw your attention to this initiative, which is called the Global Alliance Against Tropical Race 4. That was initiated in 2020. Since many partners realized, we really have to do something. To make a long story short, until now, we have a website, we have a program, but we don't have budget. Right? So that's always the problem in research. So we are working on that program, and what we have done is these 4 work streams. Now, I told you already a little bit about prevention and training, and what I, for instance, showed you in what we did in Peru, and what I showed you in the Dominican Republic, ignorance of planting 9,000 hectares of plantain and no clue whether it's susceptible to tropical race 4, yes or no. I told you sufficient about genetics and breeding, methods of control. Let me give you one example. This is what we have explored with a Dutch company and various partners also here in Ecuador. And that is a technology using UV to disinfect irrigation water. And contrary to my skepticism, Herbert Spaans here in the audience said, we should try it. So we built a coalition and we started testing first under lab conditions with equipment developed by the Dutch company to see is TR4 sensitive to UV radiation, yes or no. And we did it also for MOCO. And the surprising answer is yes, it's very sensitive, even by microspores. And MOCO is about 10 times as sensitive. So if you expose it to UV, you destroy the DNA that kills the organism. So from that, the company developed a machine where we can modulate, for instance, the flow-through speed of irrigation water through an irrigation system. We also can modulate the intensity of the radiation and also the turbidity of the water. So that's all impacting, of course, the eventual results of UV radiation. To make a long story short, under all conditions, tropical race 4 and MOCO killed by UV. And that has now been translated in machines that are currently being installed in banana plantations here in Ecuador. So we have trialed it also under field conditions in the Philippines for TR4 and here for MOCO. And the results are more than we expected even. And so this is one way of methods of control, right? How can we make sure that irrigation water that comes into the plantation from reservoirs that are, for instance, contaminated or rivers, yes, you can disinfect that irrigation water. And this does not only apply, of course, to banana production, but also to Fusarium in pineapple or in melons, for instance. So this is a promising technology. Now, the Global Alliance Against Tropical Race 4 will most likely undergo a revamp. And that is because we are now in touch with the World Bank, and the World Bank has really identified banana as a key crop. It's in their mandate, and we are struggling with global problems. And the global problem is what we discussed this afternoon: tropical race 4, Fusarium wilt, and black Sigatoka. And of course, the World Bank has a very interesting mechanism of funding research. So we are now in a trajectory of science diplomacy and to see identify donor countries that are willing to support the initiative. And then what's collected will be tripled or quadrupled by the World Bank. Let me give you one example. Italy, for instance, invested 60 million euro in a coffee program against coffee leaf rust. So this amount of 60 million will be multiplied by the World Bank 3 to 4 times. Then you're talking about a very substantial budget, right? That's the budget what you need to make global banana production sustainable, right? So, and then you not only have to focus, of course, not just on tropical race 4 Fusarium, because many of us are struggling with black Sigatoka or MOCO, in particular here in Ecuador, right? So we can address those different problems, and it's not us, the academics, that define, okay, this is important. No, of course not. It is private sector involvement. And the private sector involvement makes sure that you address the issues that are really relevant for practice, right? And on top of that, what the World Bank is proposing is a window where if you can show that you have invested in research, for instance, in local control or Fusarium control, put it on the table, and you will be eligible for a compensation of that initial investment. Right? So that's really a mechanism to make sure the private sector is involved in the program. So we're working hard to modify this program into a global sustainability program for banana. It will be international and wide, private sector involvement, and of course we are talking to governments to have governments involved as donor countries, including the Netherlands, by the way. Because here in the Netherlands, where I'm from, we import and export about 25% of the global agricultural produce. So we are an important player. So with that, I would like to finish today. I would like to thank our sponsors and collaborators, and I thank you very much again for the invitation and your attention.
El alcalde de Cuenca, Cristian Zamora, entre otras autoridades, asegurando que todo esté listo para el encuentro. Este evento empresarial parte de la 29ª Cumbre de Jefes de Estado, que reunirá a más de 700 empresarios en un espacio de diálogo público y privado. Si
Hola, tal vez preguntas, pueden levantar la mano. ¿Tenemos preguntas?
Los esperamos el 13 y el 14 de noviembre en Cuenca.
Sí, una. Ok, ya le paso el micrófono.
Bienvenidos a la experiencia de transporte aéreo ejecutivo más exclusiva del país.
Please English, yes, sorry.
Desde el momento en que llegas, nuestro equipo se encarga de cada detalle, brindándote un servicio personalizado que supera tus
Once more, if the water is full. Of course, yeah. So turbidity of the water is of course influencing the UV exposure. But we have tested until, I'm also looking at it now, I believe that 80%, right?
Puedes volar con tranquilidad
60?
a cualquier parte del país.
Speak up.
Nosotros valoramos tu
65%
tiempo y
turbidity, and
estamos
it was still
disponibles
effective.
las 24 horas del
Right,
día,
so, but
todos
of
los
course,
días
when
del
the
año.
water is very muddy, yeah, then of course UV doesn't work. So what we have done, or
Elige
what
volar
has
con
been
nosotros
practically
y transforma
installed
cada
here
viaje
in
en una experiencia
Ecuador is
excepcional.
also
Elige
a
el
filter
mejor
to make
servicio de
sure that
transporte
the
aéreo
water that
ejecutivo.
goes through the
Elige
UV
Conecta
system
Air.
Donde
is,
volar
let's say,
es
virtually
un
free of
placer.
soil particles. That's filtered out already. And that's also not super expensive. That's part of the package, so that the water that comes into the system is as clean as possible. But still, at 65%, it's still effective. You're welcome.
Perfecto, igualmente pueden devolver el equipo de traducción simultánea en la parte de atrás y nos preparamos para el último panel. Le llamamos al presidente para que nos ayude con la entrega del diploma, por favor. Un aplauso, por favor.